So here we're giving you a problem similar to 7.4 example 9 on page 679. In example 9, they have you find the cosine of 15 degrees, so I thought we'd do sine. So in here the formulas for half angles. So sine of angle over 2, cosine of an angle over 2, tangent of an angle over 2. We have these different formulas. Notice there's 3 different versions of tangent of a half angle, and you use whichever version that is handy depending on the information that they give you. So we're not going to do tangent right now, but we're doing sine. But look at tangent. If they give you information about cosine of an angle, then you're going to use this formula. If you have information about both sine and cosine, you could use this formula or this formula. So just saying. Anyway, we're doing sine. Find the exact value of the sine of 22.5 degrees using half angle identity for sine. Well, when I look at this, I say, hey, isn't 22.5 degrees times 2 equal to 45 degrees, right? Yeah, that's true. So if that's true, and I've memorized 45 degree angles, right? I know the sine of 45 degrees, I know the cosine of 45 degrees, right? So whenever, the idea is, how do you know when to use a formula? Well, if you can multiply an angle by 2 and get something that you've memorized, either 30, 45, 60, something like that, well then that's a good time to use it. So we can change the sine of 22.5 degrees and say that that's the same as the sine of 1/2 times 45 degrees, not 54. Right? Half of 45 is 22.5. Sometimes you might want to write it as simply 45 divided by 2, right? These are the same thing. You might like this better because the formulas say sine of a over 2. Now you can clearly see a is 45, or maybe this way you might get confused. So now we're going to apply the formula, right? So we're going to do the sine of a, 45 over 2. Sine of 45 over 2. And if you look at the formula, that equals plus or minus. We're going to come back to that in a second because we're not going to take both of those, but let's take a look. Plus or minus, and now the rest of the formula, 1 minus cosine of angle A over 2. And of course, this angle here is the same as this angle over here, so it's the cosine of 45 degrees. The whole reason we're using half angle formulas, I've memorized what the cosine of 45 degrees is. Back to here. This is really a 22.5 degree angle, which is in quadrant 1. Since this angle is in quadrant 1, I know I'm going to use the positive root. So I can just use the, I'm going to write it down here. I'm just going to use the positive, right? And now I can simplify things. 1 minus the cosine of 45 degrees is 1 minus the square root of 2 over 2, all over 2. Write it nice and big so you can see. So this becomes, right, 2 over 2 minus, we had 2 over 2, common denominator is 2. So 1 comes disguised as 2 over 2. So we have 2 minus rad 2 over 2 all over 2. This is the denominator that was always present from the formula. Well, think about this. Denominator here is 2 over 1, so if I invert and multiply by the reciprocal, I'm going to get 2 minus rad 2 over 2 times 2, or 4. So this just becomes 2 minus square root of 2 over 2 times 2, which is 4, and the square root of 4 is 2. So I'm able to rationalize the denominator, which is always a good thing, and our answer winds up looking like this. So the sine 22.5 degrees is equal to, we take the positive root because we're in quadrant 1, oops, we rationalize the denominator already, the square root of 2 minus square root of 2 all over 2. Now a lot of people may be uncomfortable with seeing a square root sign underneath a square root sign. Get used to it. That's the tricky part of the process.